A small block of mass m is kept on a bigger block of mass capital M, which is attached to a vertical spring or spring constant K as shown in figure. The system oscillates vertically. Find the resultant force on the smaller block when it is displaced through a distance x above its equilibrium position. Right, so the particle is displaced x above its mean position. So I can draw the free body diagram of mass small m at this very moment. That is, mg is always downward and normal is upward. Right, now if a particle is x above its mean position, so the net acceleration, I mean the acceleration of the whole system will be downward, but the pseudo force will be acting on the small mass because it is not directly attached to the spring. So a pseudo force will act on the small block, and this pseudo force will be equal to mass into acceleration. This acceleration is the same to that of the smaller block, which is downward. So I can write n plus ma is equals to mg. Fine, I have to calculate the resultant force. Ma is my resultant force, so ma can be written as mg minus normal force. Now this acceleration is of course equals to omega square x, so the resultant force is equal to mass into omega square x. In this I know the time period, that is 2 pi under root of small m plus capital M by k. So omega square comes out to be k by small m plus capital M. So substitute this value over here. I have the resultant force as mkx divided by small m plus capital M. That is my answer for the first part. Fine. And in second part I have to calculate the normal force on the smaller block. Okay. So normal force is given by mg minus ma. Okay, so it can be written as mass into g minus omega square x. Just substitute the values. I have g minus omega square is kx by m plus capital M. That is the answer for the second part. Okay, and secondly I have to find when is the force smallest in magnitude. Okay, now one thing is very clear, that I want the force, that is the normal force, to be smallest. Now this will be smallest when the acceleration will be maximum. Acceleration will be maximum when x will be equal to amplitude. So at extreme position, that is when the amplitude is maximum, normal force will be minimum. Alright. In C part, what can be the maximum amplitude with which the two blocks can oscillate together? Right, so I have to calculate the maximum amplitude for which they can be oscillate together. So the critical condition is that when normal is 0, right, at the extreme position. So if it happens, then this is my critical condition. For that I can write mg is equal to ma from this very equation. When normal is equal to 0, mg is equal to ma. Right, mass gets cancelled. So g is equal to acceleration, that is omega square of amplitude. Omega square is given as k by small m plus capital M. Amplitude is equal to g. So amplitude comes out as g times of m plus small m by k. That is the answer.